Alright, we're back in business, video number 2. I'll keep this one brief so you can get a jump start on the homework. So, the graphs of a function and its inverse are related in the following way. So you can actually look at a function and its inverse on a graph, and you can tell if they're inverses just from the way the graphs are set up. And so here's how that works. If the point xy falls on a function, and remember that idea of inverse is that you switch the x and the y, then would it make sense that the point yx then falls on the inverse? I hope it does. You take all the x values and switch them to the y's and vice versa, and you can graph an inverse. Okay? If I had just a line y equals 2x, watch this. Let's just do a quick, I'm going off the cuff here, this is dangerous. Let's go -2, -1, 0, 1, 2. Okay? We plug this in. You get -4, you get -2, you get 0, you get 2, you get 4. Okay, there's the points. If I wanted to graph the inverse of that line, I would literally switch it to be -4, -2, -2, -1, 0, 0, 2, 1, and 4, 2. Okay? If I plotted these points, and then I plotted these points, my two graphs would be inverses, okay, from one another. This is the line y equals x divided by 2, which makes sense. And what it looks like visually when that happens is that your graphs are reflected over the line y equals x. What's the line y equals x, Mr. Smith? It's this one, gang. It's just your basic linear function. Okay? And an inverse is reflected over that line. Okay, go back to our square root example from earlier. If one of the square roots looked like that, then the other one probably looked like that. Do you see how it looks like those two separate graphs are reflected over that line? That's what makes them inverses. Okay, so it says use your calculator to determine if this and this are inverses. Let's just use Desmos. If you have a calculator, you can use it, but I'm just going to use Desmos real quick. Just so we can see it, it's faster. So we got y equals x cubed, and we've got, what was the other one? Square root of x, cube root of x. How do I do cube root? I forgot. Come on. Maybe I can go in here. Aha. I'm a beast. Cube root of x. Okay, let's look at that visual. Whoa! That's pretty cool, first off. Second off, does it look like the red line, which is our first function, and the blue line, which is our second function, does it look like it's reflected over the line y equals x? I'll go ahead and plot y equals x right there for you. It sure does. You can see that it has perfect symmetry over that line, which proves graphically that these two functions are inverses. Now granted, I'm hoping we can start to realize without graphing that they are. Cube root of x and x cubed, those undo one another. Those are inverses, right? But you can test it on a graph if you need to, okay? So then the second example says, does the following graph have an inverse? If so, sketch it on the coordinate plane. Ooh, I want you to pause this video, even if it's just for 30 seconds, and try to answer this on your own. Because I know I'm about to give you the answer, but just pause it and see what you think. 30 seconds. If you don't have it solved by 30 seconds, you can press play. But see what you think. Does it have an inverse? If so, sketch it on the line. Go ahead and pause. I'm hoping you paused. If you did not, then you lame. You lame for that. So here is this graph. This looks a lot like the line y equals, man, My blue is messed up. This is y equals e to the x. Okay? And remember, inverses go right through this line. So I'm going to sketch that. And if this one is the point 0, 1, then reflect it over, switch the x and y will be 1, 0. And then imagine myself reflecting that over the line. If this is -5 and a little bit, then it'd be, if this is -5 up a little bit, then it'd be 5. Oh, you flip the x and y. Oops. So if this point, let's estimate what this is. This is, say, -5.5. Then this over here, the next point would be 0.5, -5, so somewhere down here. Okay, and I know this was kind of a cheap one because I already told you last week that these two things are inverses, natural log and e to the x. But I wanted you to also see it now graphically. Do you see how it's reflected over that line? So on some of your homework in a minute, which the homework problems are posted in the assignment, and it'll be from the textbook. I'll try to upload a picture of the textbook pages since I'm not going to be there. But hopefully somebody has a book that you could take pictures from, if not. But just a reminder, if you're looking at an inverse graphically, you switch the x's and the y's. And a way you can see that visually without actually manually switching them is that it is reflected over the line y equals x. Just like this was, okay? That is y equals x cubed. That is y equals the cube root of x. And look what they look like when plotted together. They are both symmetrical about this line, y equals x. So that's your summary, and that's a big takeaway for inverses. So I told you this video was going to be shorter. I hope this is helpful. You can get a jump start on your homework, and any questions that arise, please jot them down and bring them with you to class next week. The snow day kind of messed us up this week. I did not really get to see you guys that much. And so please bring questions next week, and I will answer them all. Keep working hard. I know it's tempting when, snow days, they kind of fall behind in the homework, but our test is coming up. Okay, our test is coming up, and I want you guys to do well on it. So stay locked in, stay motivated, get you some caffeine. I appreciate your hard work. Have a good one.